All right, guys. All right, new lesson, page 206. This is called Arithmetic, Sequences and Series. I don't know. So it depends how far we get. Arithmetic, sequences and series. You may possibly have done some of this in geometry. You may not. You'll definitely see it in future math classes as well.
I actually can't remember that far back. I can't remember what I have for lunch yesterday.
Okay. All right, so first of all, let's talk about what a sequence is. Sequence is an ordered list of numbers period. Each number in a sequence is a term of the sequence. So the first kind of sequence we're going to talk about, there's arithmetic and geometric, okay? So today, the first one we're going to talk about is an arithmetic sequence. An arithmetic sequence is a sequence where the difference between consecutive terms is constant. The difference is called the common difference, and is referred to as D. So, for example, is the sequence 6, 10, 14, 18.
Excuse me, Miss Rayleigh.
Yes,
Do you have Skylar Johnson?
I do.
Can you send her the guidance, please?
Sure.
Thank you.
You're welcome. 6, 10, 14, 18, dot. Is it arithmetic?
No.
Almost said Skylar arithmetic. What'd she say? Guidance. I would think. So what y'all say, yes or no? Yes, it is. Arithmetic. It said, okay, so if so, what is the common difference? 4. So in arithmetic sequence, you're adding the same number every time. Plus 4, plus 4, plus 4. Or plus, it could either be like a plus, a minus 2, which usually we just say minus 2, minus 2, minus 2. But you're not multiplying or dividing by the same number each time, okay? It's adding or subtracting the same thing each time is an arithmetic sequence. And whatever that number is that you're adding, that's called the common difference, and we refer to that as D, because you're going to have a formula, and in the formula there's a D, and that's talking about that number that you're adding or subtracting each time. Okay? We all right so far? Yes, Miss Riley. Okay, cool. So that formula is called an explicit formula, and when you see it, you'll know if you've done this before or not. An explicit formula can be used to represent terms or find a certain term. For an arithmetic sequence, the nth term is given by the formula here it is. It is A sub n, so that's like a little subscript, equals A sub 1 plus, open parentheses, n minus 1, close parentheses, D. So why they put the D on the back side of the parentheses and not the front side, I don't know, because it's still being multiplied by whatever's inside parentheses. And that's for any number where n is greater than or equal to 1. And that makes sense because it's like, what's the 10th term in the sequence? What's the 100th term in the sequence? You have to, you can't have what's the negative 10th term in the sequence. That doesn't make sense. Okay? So over here on the side, I'm going to tell you what each of those variables stand for. Make sure you write that down in your notes, because every single year when I give these notes and kids don't get it, and I say, let me see your notes, so show me what these variables stand for, because they don't know. They didn't write it down. So make sure you write it down. Okay? Oh, let me tell you what the problem is. Let me give you a problem. We'll do that on the next page. Let's do this. D is the common difference. So like that's the number that you're adding or subtracting every time. So above, that would have been 4. 6 plus 4 is 10. 10 plus 4 is 14. 14 plus 4 is 18. N is either N, yeah. N is the term number you are asked to find. And A sub 1 is the first term in the sequence. Cool beans. So let's look at an example. Page 207. Find the 20th term of the arithmetic sequence. And my sequence is 8, 11, 14, 17, dot, dot, dot. Now, when I was in school, I remember we had the standardized tests. I mean, we didn't have the FSAs or EOCs, or we had something else back then, way back then. And I remember we had questions like this. And I'm sure they taught us this formula, but I don't remember using it. So when we had a question like this, I would literally write this out until I got to the 20th term, and that's the answer, right? So you can totally do that, and you're going to get the same thing. But if they said, what's the 100th term of the sequence, that's going to take a lot more time. And on a timed test, you don't have that much time. Or what's the 1000th term of the sequence? Well, I might have skipped that and come back to it if I had enough time. But if you just knew this formula and knew what the parts meant, then you could just find it really easy instead of having to write out all the numbers until you got to the 100th term or the 1000th term or whatever term they were asking for. You know what I mean? But if you get stuck, then you just do that. So our formula is A sub n equals A sub 1 plus open parentheses n minus 1 close parentheses times d. Okay, what is D in this case? 3. Everybody get that? Because 8 plus 3 is 11. 11 plus 3 is 14. 14 plus 3 is 17. Therefore, D is 3. That's the common difference, right? So we know we're going to end up putting a 3 there. What is N? 20. That's the term that they asked us to find. What's the 20th term of the sequence? N is 20. What is a sub 1? 8. That's the first term in the sequence. Why do I keep doing that? Boom. Now we just substitute it in. So this a sub n, now if they told us the 20th term in the sequence, we'd put a 20 there, okay? But they said, what is the 20th term? So this is just, that 20 is a subscript. We are looking for the 20th term. So that's just telling us what we're looking for, okay? That's like a function, you know, like our input. So to find the 20th term, we take our first term, which is 8, plus the term we're looking for, which is 20. We subtract 1 and multiply that by the common difference. Make sure you take care of your order of operations correctly. So that's going to be 8 plus 20 minus 1 is 19 times 3. What do we do next? 8 plus 19? 19 times 3. Multiplication comes before addition. So that's 8 plus 57. And the 20th term of the sequence is, what'd you get? I got 65. 8 plus 57. Make sure I did it right. Yeah, 65. Easy, right? You have a question on that? Okay, good. All right, how about this one? Find the 32nd term of the sequence. And the sequence is 9, comma, 4, comma, -1, comma, -6, comma, -11, comma, dot, dot, dot. I'm gonna write my formula again. Thank you. Okay, what is D? Good. -5. I'm subtracting 5 every time. Test, yes. Wait a minute. What is N? 32. So the term number they asked me for, right? And what is A sub 1? 9. First term of the sequence. Y'all work on that while I go get this taken care of, and we'll see if we get the same thing. got negative 46 and negative 146. You got negative 146? Okay, let me see. Alright, so we have a sub 32 equals my first term plus 32 minus 1 times negative 5. So that is 9 plus 31 times negative 5. Do your multiplication first. So positive 31 times negative 5 is, you could say plus negative 155 or just 9 minus 155. Either way, you get negative 146. Anybody have a question? Comment? Concern? Okay, let's do a word problem. On page 208. This is easy, right? Test on this all day long. A student deposits the same amount of money into her bank account each week. At the end of the second week, she has $30 in her account. And at the end of the third week, she has $45 in her account. How much will she have in her account at the end of the 9th week? Did it tell us how much she had in the account in week 1? No. Did it tell us how much she had in the account in week 2? How much? 30. How much in week 3? 45. How much must she have had in the account in week 1? 15. Because it said she deposits the same amount of money into her bank account each week, right? So she had to have started with 15 if she went to 30 and then 45. Okay? So I want you to find out how much she's going to have in week 9 by using the formula, not just by adding 15 until you get to the 9th week. Anybody know? Yes. 135. Anybody get anything different? I got $135 too. Nice. So what is D? 15. N is 9 and A sub 1? 15. So we are looking for A sub 9. So that's 15 plus 9 minus 1 times 15. So that's 15 plus 8 times 15. What different way is there?
It's not like I just figured it out, but for this one I subtracted 3 from 9 and then I multiplied it by 15 and then I added 45 to it.
So you didn't use the formula.
They were saying something
Hold on, I have to look at it when I finish. Like all the notes. Anybody have a question about that? Easy, right? Okay, so that's called the explicit formula on an arithmetic sequence. So now I'm going to show you about an arithmetic series. So it's the same thing except for there's still, you're adding the numbers together, okay? So instead of, there's still the same difference between the numbers, but I would be doing like 15 plus 30 plus 45 plus 60 plus 75. And I would say, what is the sum of the first 50 numbers in the series, okay? So that's called an arithmetic series, which is what we're going to do next. And so it's easy too. You just have a formula, substitute the stuff in, and there you go. All right, no big deal. So I don't have much more to go. Page 209. We'll get through this pretty quick. As long as you know what the variables mean, no big deal. All right, this is called arithmetic series. An arithmetic series is the sum is when you add the sum of terms in an arithmetic sequence. So in a sequence, you're not adding anything together. The sum of a finite series, do y'all remember what finite means? Y'all know what infinite means, right? Finite is the opposite of infinite. Infinite goes on and on and on and on. Finite ends. So it's the sum of a finite series can be found with the formula, with the following formula. And that formula is S sub n equals n divided by 2, open parentheses, a sub 1 plus a sub n. So a sub 1 is the first term. In the series. A sub n is the last term in the series. So when we were talking about arithmetic sequence, you didn't get the last term, but with arithmetic series, when you're adding them all together, you have to know what the last term is, okay? So a sub n is the last term, and an arithmetic series, n is the total number of terms in the series. And it's confusing because you have an a sub n and you see an n there, okay? And you see an n here. But a sub n is this whole thing. A sub n is the last term in the series, where n by itself is the total number of terms in the series. Can somebody open the door for her, please? And this n is this n. Okay? Okay. Give me a second. All right, so example. Find the sum of 5 plus 10 plus 15 plus ... 150. So we know it's arithmetic because you're adding the same number to get to the next. 5 plus 5 is 10, 10 plus 5 is 15. So that's what makes it an arithmetic series. But we are adding all of these numbers together, okay? So you take your formula, in this case, a sub 1 is what? A sub 1 is 5. It's the first term of the series. A sub n is the last term of the series, which is 150. N is the total number of terms in the series. It doesn't tell us that. 150 is the last term, and it goes by fives. How many terms do you think there are? 30. Just take that last term and then divide by, basically think about it as the common difference, okay? So in this case, there would be 30 terms in this series. Does that make sense? They didn't tell us that information. We had to figure that out. All right? So this S sub n, so we're looking for the sum of the first 30 terms of the series. That n is 30. So you take 30 terms, divide it by 2, times the first term in the sequence plus the last term of the sequence. So the sum of the first 30 terms of the sequence, that would be 15 times 5 plus 150 is 155. Multiply those together. 5 times 155 is 2,325. So if we wrote these 30 terms out, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, all the way up to 150, and we added all those together, added them all up, we would get 2,325. So that would take us quite a bit of time to do. Not a long time, but probably a lot faster to do this formula than to add all those up. You know what I mean? You know what I mean? Oh, we'll go with yes. Okay. Let me try to get one more in here really quick. Page 210. What is the sum of the even integers from 2 to 100? Okay, so they didn't write the numbers out for you, did they? What is the sum of the even integers from 2 to 100? So think about it. So it starts with 2, even integers. So that would be 2 plus 4 plus 6 plus 8, all the way to what? 100, right? So they didn't write that for us. We had to think about it. So a sub 1 is our first term, which would be 2. A sub n is our last term, which would be 100. And n is the number of terms in the sequence, which would be 50. Take that last term and divide by, think about it as the common difference. So we're looking for the sum of 50 terms. So we're taking 50 terms, dividing by 2, multiplying that by the first term of the sequence plus the last term of the sequence. So that's going to be 25 times 102. If we add 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 all the way up to 100, we would get 2,550. Coolio? Not too bad, was it? Let me give you one more to do on your own. Find the sum of, oh, I'm sorry, yes. Thank you. Three plus 5 plus 7 plus making this one up. I haven't figured it out yet. I didn't figure it out yet. I made it up in my head. Hold on. Sorry. I don't know if that's gonna work out right. Might have made a mistake. Go back and look at my numbers. 4, 5, 6, 7, 8, 9, 10, 11. Yeah, that one's not going to work out right. Alright, we'll have to edit this out of the video. Because if you add them all up, that's not going to give you a decimal, but when you divide, that would give you a decimal, so that's not going to make sense. So, we'll just forget about this one. Well, now that you said that, we'll go on.